point. I guess it will be multi-part video. Okay, so here, for instance, is the rubric from last semester for this for a problem. And basically it's saying, okay, I've got this function here, okay? So I've got this file here, and it's a file of purchases. And I only want to know purchases that are of a certain category, right? So like the field might be like category, item, date, amount, whatever the order is. And the goal is for you to basically filter, it's basically saying sum up only stuff that was in this category, right? Give me the total price of stuff that's on. Make sense, everybody? Okay, so here's the breakdown of the points for this 20-point problem. Writing the code as a function, because I say write a function. Reading the file. Accessing the individual data fields. In other words, can you do the split operation to split it up into the fields? Performing a running sum. Okay, did you set up a for loop to actually add up all the stuff, to add up those numbers? Are you adding up the numbers? Are you adding up only the things in this category? So notice that basically, and then returning the sum. So if you go through this, this is actually a step-by-step guide on how to do the problem. Create the function, use open and read lines to read the file, get the data fields, so use the split to access the data fields, perform a running sum, so now that I've got the data, so I've got to do a for loop around that split, right? Summing the purchases, so let's go ahead and add this specific field, and only the correct items are summed. Okay, got to add an if statement. And if you need to like do stuff like you've written your total is equal to whatever, right? One of the advantages of paper is that you could totally write an if statement right here, right? If you needed to. And if you need to draw arrows to say, I'm inserting something into here rather than rewriting the entire thing, as long as it's clear, that's all I care about, okay? So your code can be a bit unorganized if it has to be, okay? So again, these rubrics will be guides on better guides than what you see on the PDF. It will be very, very helpful for you. Okay. So with this being said, let's take a look at this one that actually has appeared on a previous exam, which is one I've showed you before, temperature.csv. We've got a file that contains high and low temperatures in Philadelphia, composed of 3 fields per line containing the date, the high temperature, low temperature. Each field is separated by commas. For example, the contents of the file might look like this. And you are going to get example files. The ... dots aren't literal. They just simply say, hey, the file continues on in the same manner, right? And this is just simply an example, right? So hard coding this into your answer is not going to help, right? Because this isn't the answer. This is just one potential file you might get, okay? It's from 2019, in fact, so you probably would be working on something else. So we want to calculate the highest high, the lowest low, and the average high temperature. So let's go through this. Okay. So first thing we need to do is read this file. Did I give you a file name? Yes, I did. It's called temperature.csv. Okay. So let's go ahead and def read temp. Typically, I'll say, hey, I'll give you the file name as an argument, okay? What does that mean? It means you get to be lazy and say basically the open command, I get to just simply say open file name. If you want to be really fancy, you even add R, for read. But you don't actually need that if you just simply put open file name. Python's just going to assume that you're in read mode. Other languages will actually require you to be specific, but Python's pretty good about this. So I'll say file is equal to open the file name. And then next thing I want to do is actually kind of translate this. Lines is equal to file.readLines to get all the files into to get each line as an individual string. Okay, I didn't explicitly say this in here, but I do explicitly say it on the exam. There is no legend statement, right? There's no first line that explains what everything is. It's just data. So you don't have to worry about like throwing away the first line. Make sense? Right? It's just simply saying, here's the data, here's what it is. Okay. So now that I've got this data, let's go, we got to go through it line by line for line in lines. For each line. Each line has parts, right? So we should separate it into parts. And I'll just be very explicit about that. Parts is equal to line dot, and then we split the line. It's a string. Each individual line is a string, right? And it says each field is separated by commas. It's separated commas. I didn't say separated by commas, apparently. I said separated commas. Okay, so, but if you see here, we've got our date. And the spacing is just because of the formatting of the PDF. It's not actually necessarily got spaces. It's just the formatting of the PDF. Okay, 11. So we've got 3 fields, right? Date is equal to parts 0. High is equal to parts 1, and that was a number, so I'm going to go ahead and remember to turn this into a number. If you forget to do that on a 20-point problem, that's going to most likely be a penalty of 1 point if you forget it, because this is one of those super things that if those super easy things to fix if you forget it, right? Like the program will spit out, oh, you forgot, you can't add integer and string. Right? So easy to fix, but not technically fully correct, so we do give a penalty for that. High, low is equal to int. And I do plan on uploading these as soon as like I dismiss class, so that's my main focus at the end of class, which is uploading these files. Okay, for line in lines, we've got our high, we've got our low, so we've got these. Now we had 3 questions. We want to know what the highest high was, the lowest low, and the average. So we'll work on adding those individually rather than writing 3 separate programs. So the highest high. So do I care the day with the highest temperature? Yes, the day with the hottest high temperature. So I'm going to create hottest is equal to, I'm pretty sure that's below absolute 0. So I'm starting with a very small number. So any number is going to be higher than that. Okay. Similar, and then and I'll just simply say hottest day is equal to blank. Okay. This is just basically I'd say this is like our starting value for temperature. It's a very low temperature, below absolute 0, simply because we know we can get a temperature. Any temperature will be hotter than that. So if high is greater than hottest, then that hottest temperature is equal to high, and hottest day equals date. Then we do the same thing for the low temperature. Coldest is equal to, and let's just make it really big again, coldest day is equal to, and then if if low is less than coldest, then the coldest is equal to low, and coldest day is equal to the date. And then finally, it was asking us for the average, right? The average high temperature. So I'll call it total hot. And num days. This is easy enough to do. Total hot temperature starts at 0. We're going to add up to do an average, we add up all the things we want to, all the things we're averaging, and then divide it by the number of things we added. So over here at the end, what I'll do is I'll say total hot is equal to high, or rather plus equals high, total, and then num day plus equals 1, right? For each temperature that we read, or for each day that we read. And then the average hot is equal to total hot divided by the number of days. As far as returning goes for this one, I mean, for this one, we could return all three. Return hottest day, coldest day, comma, average hot. Python allows you to return multiple things. Most languages only allow you to return only one item. Python allows you to return multiple items. Except that's a lie. Python technically cheats by returning one item. It just packs all those items into a single item, which then can be automatically unpacked, and it just is like, it seamlessly pretends that it can return multiple items. But otherwise, you would write 3 separate programs to return those things. Okay. Again, I will be releasing this like as soon as, I'm going to be uploading this as soon as this lecture is done. Okay. So extra practice, I'll come back to this if I have time, but what you do is you do this very similar thing. Read the file, split it up, and then and then you would iterate again over each part. It would be a nested for loop. So you'd have a for line in lines and then for a number in parts, and then you'd check if that number is even. And then if so, add it to your running sum. Okay, method writing. Once again, I go through these. I went through these and modified my exam on Sunday to make sure that I had some new problems. But each of them, they will have a rubric. Except for one, isval. Oh, I guess you know that's on the exam now. So isval has no rubric because that's just very simple. It checks you're returning true or false if this thing is val. I can't really get more simple than that, right?
Is val on the practice exam as well?
No, what we've done in class. Now that being said, that part is part of a larger problem. For that one, for that one, I tell you, okay, you write this as a function so you can call it in the second problem, like part 1 over here, then part 2. That way your code gets a little less messy. I automatically break it up for you, which also should let you know that if you feel the need to, you can always write more functions. Nobody can stop you. There's no function police. Okay, if you need to write extra functions on your exam, which you probably won't need to, you have that ability. Okay? So let's go ahead and work on this problem. Un or un? Okay. Given a word, if it starts with un, we remove the un. If it starts with no un, we add an un. So the first thing we need to, so basically this becomes this is actually a very short program based off of an if-else statement, if it starts with un or not. So we need to check if the first 2 letters of this string, of the string start with un. You can assume that the string is 3 characters long, so we don't have to do any length checks or anything here, right? So if the word starts with un, so how do we know? In Java, they have actually a starts with function, but we don't need that here. We just simply will do a slice. If word and the first 2 letters of the word will be 0 up to, but not including index 2. So index 0 and index 1. You could also just write this as this. If that is equal to un. So if the first 2 letters, index 0 up to, but not including index 2, so index 0 and index 1, are un, then we want to return the word without the un attached to it. So word, and we want to slice it again. Okay? So we want to have everything but the first two letters. So the first two letters are index 0 and index 1, so we want the return string, the part without the un, to start at index 2. And then it should go to the end, and we can leave that part blank, because that will automatically go to the end. Okay? We don't need to say, next we don't need to check if it doesn't start with un, right? We don't need to say if word 0 to 2 not equal to un, we can just do an else here. Or we can even just kind of do a default. We don't even technically need the else, but symmetry here is nice. We could do return, and then we just need to add un in front of it. Un plus the word. And that's it. A lot of the problems, this is the issue with programming. Or at least the beginner programming, once you see the answers, it's hard to unsee them or see how you didn't see them in the first place. So that can be very frustrating. And a lot of stuff is simpler than it appears to be. Okay, next one, min-max.
You cannot unsee the answer.
Well, you can't. It's just like you can't go back to the practice problem and pretend to do it again from scratch without having the without having the memory of this. I mean, you could forget, but it's hard.
Can do it from scratch again, or
It's hard to. It's hard to unsee the answer. Okay. Given a list of integers, return the difference between the maximum and minimum element. You can assume the list will have 2 or more elements in this. Now, this is one of those ones where if you remember your Python, it's actually quite easy because you could go through and basically do, you could create a for. Don't write this down, because this is the dumb way to do this. You can go biggest is equal to, number. You can assume that the first number is the biggest number, right? And then do a for loop, blah 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 blah, and say if n is bigger than biggest, right? Then that's right, and you can do that for the min and max. Or you can just remember your Python syntax to automatically do it for you, which is return max of numbers minus min of numbers. This one's actually a lot harder in Java, where there isn't a built-in min and max function. Don't be afraid to use built-in functions. If it's part of Python, or you import a valid Python package, it's valid in my book, right? I don't care so long as it works. I don't care how inefficient or messy or whatnot it is. If it works, it works. Okay? If I'm grading you on efficiency, I'll be explicit about grading you on efficiency. And guess what? I don't do that until the 3rd class. I don't do that until 2168. And then even then, I'm very explicit about what I'm grading you on. That's got to run in this runtime, which generally means you got to do this problem and you can't use nested loops to do it. Okay. Skip this one because, again, I want to make sure I have enough time to hit everything, the extra practice. But to swap the ends, right, the key to swap, in case I don't get to this one, the key to doing any kind of swap is that you have to have 3 variables. You have to have the place the first one is at, the place the last one is at, and then you have to have a temporary location to save one while you overwrite the other. Or, alternatively, you can use the technique, the super secret technique that I showed you in exam 1, which is a way of adding numbers together to do an in-place swap. If you remember, there was a problem in exam 1 where basically I did a bunch of addition operations and A ended up as B and B ended up as A, right? That's called an in-place swap. So, but most of the time when you swap stuff, you use a temporary variable. Okay. Given a list of things, return the first half of the list. A list of things, very specific. But that means we just don't care what it is. Now, okay. Now, this one I was kind of annoying because I said, wait, first half, right? What if the number of things I have is odd, right? Right, if I have an even number of things, like 1, 2, 3, 4, 5, 6, I have 6 things here, I return 1, 2, 3. That makes sense. But what if the things are odd? This is where where I'm often much more explicit about that in the directions. Sometimes I'll even say, it's up to you what to do. But here I just assumed you're going to be smart and go off of the examples I gave you, which says, oh, if you have 5 things, you're just going to return the first 2, right? This is the first half. That's the second half. The thing, this middle item gets split up over here. Same over here. First item's over here. So it doesn't matter if it's numbers or not. So first half. Return the first half of the list. So so often when we have this kind of edge case over here, we can waste a lot of time by obsessing over this edge case. Don't do that. Focus on the general case first, and then see if you have to modify your problem at all, and see if it might be that basically that the solution just emerges naturally as part of it, and it's not something you actually have to worry about. So let's assume that for the sake of argument, that we're going to get an even item, okay, an even, or an even number. A list with an even number of items. Okay. We could. This is just a slice problem. We could solve this with one line again, because it's, again, slicing. So how do we slice the first half of the list? Let's go ahead and, let's not do that. Let's go ahead and just basically figure out in order to do this, we need to figure out what the middle index is, right? So we've got, let's look at the letters for a second, because I don't want to have to say, oh, the middle index is at for this one is 1, 2, 3, that goes through index 3, but does not include, you see how having 3 there makes it a bit harder, because I'm using indexes as numbers, and I'm using numbers as indexes and values. So let's go with A, B, C, D, E, F, G, H, right? 0, 1, 2, 3 are the indexes. 4, 5, 6, 7. Okay, those are the valid indexes, 0 through 7. It's length 8. So the indexes we want to return are 0 through 3. Okay, it is 8 long, so we want to return every index before 4. Right? So 8 divided by 2 gives us 4. Right? Why am I dividing by 2? Because I'm splitting it in half. Half. Right? Everybody following that? I'm splitting it in 2 because we're splitting in half. So can I just simply take the length of a list and divide by 2? So let's go ahead and test this out. 8, I want to go up to, but not include index 4, so which is 8 divided by 2. I want to go up to, but not include index 3, which is 6 divided by 2. Okay, what about this one? I want to go up to, but not include index 2, which is 5 divided by 2 if we do integer division, right? So, okay. So the middle index is equal to, or quote unquote midpoint is, it would be the middle at this point. Would be the length of the list divided by 2. Right? What if you did float division? Assuming I caught it in the first place, it'd be a point off, because it's one of those, again, things that are easy to check, because I care more about the problem solving process than the syntax. I mean, the syntax is important, but in terms of like whether or not you give me gibberish or not, but as long as you're just giving me something that, if you make minor syntactical errors, it's like forgetting to put a comma on an English exam where you're turning in a whole paper. Okay, you forgot to capitalize something, you forgot to put a comma here. Depending on one professor or another, they might be very strict about it, but like, at the end of the day, it's the argument that's more important. If the argument is coherent, that's what we care about. Middle, there, and then we return the list from the beginning up to, but not including the middle index. Okay. One of my personal favorites. Write a method called hasWildcat. Given an input string word, return true if the word contains cat in it, but the middle cat can be the middle A can be any character. So what do I mean by this? Okay. There are a couple ways. Now I like this one because there's a ton of ways to do this one, and some of them have their own pitfalls and stuff. If you use slices, it gets rid of most of those pitfalls, but I'm going to assume for the sake of argument you might be blanking on using slices. So let's look at it. Kitty does not contain CAT in it, so we return false, right? Tomcat has CAT in it, so it returns true. Make sense? Catnip in LeetSpeak has a cat in it, a wildcat as we say, because it's C4T. So it's basically we're looking for a C followed by any character followed by a T. Make sense? Or, even easier, a C followed by a T 2 characters after it. Right? Ignore that middle character. So, when we are iterating over when we iterate over a word like this or anything like this, we need to be able to care about the index. So there's two ways we can care about the index. The first is to do what I assume you're going to do on the exam for index in range length word, right? That's how you basically say, hey, it's 0 up to, but not including in this case, 6, right? That's how I assume you would do it on the exam. And then you would say basically letter is equal to word at that index. Make sense? Another way to do that is that, again, I've only showed this once in class at random before, but there's this special keyword we can use instead. We can do for index, comma, letter. And then we use a big word here, enumerate word. And this single line does basically the work of both lines over here. Make sense? Either one, you can start with either one. Okay. Now, assuming I forget that slices exist here for a second, let's go ahead and do this one without slices. Okay. If I do, so basically, I don't have to care about any characters after the C until I hit a C. And the other question is, what should my default case be? Right? For a lot of these true-false cases, you want to have a default. So in this case, I'm going to assume false. Why? Because most words don't have CAT in them. So, and then as soon as I find a CAT in it, it's true, so I'll return it. Make sense? So letter is equal to word, word index, if letter equals C, and we're going to just assume that everything is like lowercase or whatever. Okay, it doesn't matter. I didn't mention anything about cases. I'm not trying to be tricky about cases. It's not I don't do those kind of trick questions. If letter is equal to C, that's what we care about. Okay, if letter is equal to C, then I need to make sure that the letter 2 characters after it is equal to a T. So word index plus 2 equals T. Return true. We found a wildcat. So let's go ahead and test this out just to kind of show you, because this answer is almost completely correct and would give you basically 7 out of 10 points. Let's check it out on Tomcat. It should work on Tomcat. It doesn't print anything, of course, because I didn't tell it to print anything, so. But it didn't error, so you know. Here's the. So run it. True. Tomcat, cat, nip. True. But if I try it on kitty, I get false. Okay, that's fine. But here is the issue that we get. What if I try it on something like taco? I get an error. Why do I get an error? I get an error because index plus 2 goes out of bounds. Right? Right? And what happened when I was checking taco, once we got a C, once we hit the C, we tried to look 2 ahead, and that would check me, and that would go past O and into the abyss, so to speak. So how do we get around this? 2 ways. Way number 1. Well, if I'm looking 2 ahead, I'll subtract 2 over here. Why? Because if I'm looking for a cat, as soon as I do these first 2 characters, TA, these last 2 characters, I know there can't be a cat in there because it's only 2 characters long. There's got to be 3 characters left, so I can subtract 2 over here to say, okay, I don't have to look at those anymore. Okay? The other way you can do this is the way I suggested in Hawaiian pronunciation, which is I'm going to go ahead and comment that out. Instead do, well, not Hawaiian pronunciation. No, slices would actually be a bit tricky. The other way is to use slices, and the fact that slices don't go out of bounds, but it's a bit, the slicing is a bit weird here, so I would avoid it. The way I showed you earlier is probably the best way, but you could use slices, and the fact that slice notation allows you to like skip letters, right? The third argument in slice notation to go up by 2 to get to another one. But that would do that honestly, I think about it and it looks ugly. So okay, is everywhere. So let's see, how much time do I have? So I have time, but I want to make sure I get enough to go over these other problems. I want to make sure I do the required problems. So I'm going to skip back past these extra practice ones right now. Is everywhere, basically, what you're trying to say is you're looking at this pair. Basically, you're doing you're moving to the right and looking at slices of 2, and then asking if this slice of size 2 has this item in it. And as soon as you find one that doesn't, you return false. Otherwise, you can assume that you return true if you get to the end. Okay. Given a string, return the sums of the digits that appear in the string, ignoring all other characters. Return 0 if there's no digits in the string. Note, s.isDigit tests if a string s is one of the characters 0 through 9. So here we've got A, B, C. Here we've got A1, BC2, D3. The answer is 6 because you have 1 plus 2 plus 3. This one is 8 over here because you have 1, 1, 3, 3. 1 plus 1 plus 3 plus 3. Not 11. And it's not 44 because that would be a lot harder, to be honest. Okay, so. And this does help you kind of figure out the next one. Okay. So next. Okay. So, some string digits. So what we're going to have is a total is equal to 0. We're going to return that total at the end. And of course, if we add nothing to it, because like we've got a word like chocolate, then we're going to be returning 0, so that solves our issue there. So, let's say L, or let's go with C in Word for C, character C in Word. If C dot is digit, it said, was it capitalized or not? Not capitalized. if C is digit. Yep. And then you could say equal equals true, but honestly, you can just do this. That will return true or false. Sorry, not question mark, the colon, right next to each other. If it is a digit, then what we're going to do is we are going to, we would like to do this, right? Total is equal to total, what we currently have, plus C. But remember, this is still a string, so we have to do this. We have to convert it. C is equal to int C. We could also just alternatively just do that here. You could also do that as a plus equals instead of a total is equal to total plus C, int C. But there you go. That's how you do it. That one is fairly straightforward. A lot of these are fairly straightforward, I think. Sum of the digits. Given an integer, return the sum of the digits of 0 to 9 of that integer. Okay. And for students who have made it this far and are checking into the recording, and for those of you who are here, let me just give you a warning about the hardest problem on the exam. The hardest problem on the exam is only worth 10 points, even though some of the problems are worth 20 points. Those are not the hardest. And I do mark the hardest as the hardest one. I say, in my opinion, this one is the hardest one on the exam. Please skip it if you think you are having trouble. So I'm going to give you a very big hint. Very, very big hint. Okay? The hint is that we actually solved part of this problem, or part of the problem of doing that problem, I should say, all the way back on the Madhava-Leibniz lecture, where we had to, and that was the one where we were approximating pi. What was that one? That one was doing the 1 minus a third plus a fifth minus a seventh, right? And we had to solve multiple parts of that, right? Alternating between adding and subtracting, or doing a for loop so that we could keep adding a running sum. And then the third part of that was also doing fractions, right? The hardest problem on the exam integrates one of those challenges as a core part of that problem. So I would go back and review, okay, how do I do an alternating sum, or how do I turn things into fractions? Because one of those is the core concept, right? And that's in the Madhava-Leibniz lecture, which is recorded, and it's labeled as Madhava-Leibniz. It's approximating pi, okay? It's not the approximating pi that's part, it's the steps we had to go through to get there, right? So we did that all the way back like at lecture 5 or lecture 6. Okay. So there's your hint, right? And I'll see if this, if I get more students this semester who get this one right, because it is a challenging one, okay? Now, going back to our exam, we were talking about summing the digits. Okay. Oh, and that's not a hint. I just know that basically that problem is geographically, like physically on the exam, close to the equivalent. It occurs very close to this problem's equivalent on the exam. Okay, that's.
So it's similar to this problem?
No, it's not. It just occurs nearby it. I'm saying it occurs geographically close. Like
There's no problem like that on the practice exam?
no, not really. He gave you the hint. I mean, kinda, but you'll see. Just take my advice. Okay. Anyway, summing the digits. So this one has two solutions. The one that I dislike because I'm me, and a lot of students do this one, right? But they all revolve around this. You have a total is equal to 0 again. You return total. If you do that, you're probably getting if you do just that, you're getting like 2 points because it'll be according to the rubric, right? setting up a rounding sum and doing this. So again, a lot of students will try to do this, 4-digit in num, right? Total is equal to, total plus equals digit, return total. Right, but if you try to do that, you're going to be in a world of hurt because that doesn't work on integers. Right? It will give you this error, type error, int is not iterable, meaning you can't do a for loop on an int. You're most likely, what you're thinking of is doing this, a range, and you don't want a range here because that would be all the numbers from this number to this number. What you want are the digits. So the way I dislike solving it, but is very effective, is you convert this number into the number into a string, which now creates a different issue, which is you can iterate over it, but you can't add ints and strings together because the entire thing's a string now. So you basically say digit is equal to int digit. So you turn the integer into a string, and then you turn the string, each part of the string, each individual character in the string back into an integer. And just a lot of conversion. It's wasteful. That's why I dislike it, because that conversion can be expensive. But like, again, if you wrote this on the exam and gave me this, I'm going to give you full credit because it works. Okay. So what is the efficient way to do it? The efficient way to do it is to use math, to use division and modulo. So sum digits, total, I'm going to call this sum digits 1 or 2 because we're doing another variation of it. While, I'm having a great time spelling. While num is greater than 0, okay? I know that sounds weird, but while the number is greater than 0, what are we going to do? We're going to say, we're going to get the ones place as the digit. We're going to get the ones place, which in this case would be the 4 over here. We do that by saying digit is equal to num mod 10. Oh my gosh, 10. Num mod 10. Why num mod 10? Because when you divide, when the remainder after dividing anything by 10 is going to be the ones place. Make sense? So that gives you the ones place. So in 1,234, if you divide that number by 10, your remainder is going to be 4. Okay? We're going to add that to the digit, and now we need to get rid of that so that we can work on 123 instead of 1,234. So how do we get rid of the last digit? We do num is equal to number divided by 10. And you can do this, you can do either of these lines first. It doesn't matter which one you do first. You can do the addition or you can do the chopping off. So remember, modding by 10 is the equivalent of saying, let me get the rightmost digit, let me get the ones place. And dividing by 10 is the equivalent of saying, let me throw away the ones place. Okay? Very useful operations there. Okay? And so you can do it like that, and it'll be a lot more efficient because you're not doing any conversions. You're just doing mathematical operations, and your computer's good at doing those mathematical operations. Okay, but also it's like such a small, relatively small thing for the computer that's not going to really care. But it's good to know how to do it both ways. All right. So I believe I've done this one in class already. This one I did. This Monopoly problem in class once already. But I have a different Monte Carlo problem that I haven't gone over, so I'm going to skip to that, which is this one. Okay. For those who are curious, this particular scam is called Penny's Game, Penney. Right? So this part's all true. The outcome of any fair coin toss has an equal chance of landing on heads or tails, okay? It's true. Any fair coin toss gives you heads or tails. If I were to toss a coin 3 times in a row, there's 8 possible outcomes. All are equally probable. And this is true. All these outcomes are equally probable. I could have all heads, all tails, or some other permutation of heads or tails. Those are the 8 possible outcomes. All are equally probable. All have a 1 in 8 chance of occurring, right? Make sense? This is not the scam part, okay? This is where our scam comes in. Suppose Professor Rosen challenges you to a coin flipping game for $100. You choose a sequence that occurs after 3 coin flips, such as head, head, tails, and I'll choose a sequence such as tails, head, head. And then one of us is going to keep flipping the coins until one of our 3 sequences occurs. And whoever one shows up first will win. So if we flip the coin until the chosen example sequence occurs, a few games might look like this. Head, tail, head, tail, head, tail, head, head. That's my win because my sequence is tail, head, head. Here, we do head, then we flip into the coin again, head, and then you flip it again, and now it's the tails, and you win. Here, we flip the tails, and then flipped another tails, and then heads, and then a tails, and then the heads, heads, and then I won because tail, heads, heads. And here, we flipped heads, 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 tails, right? You won. Okay, now this seems like a fair bet because all 8 outcomes are equally probable of occurring. Then you remember Professor Rosen mentioned he was sorted into Slytherin as a bit of a trickster and probably won't be challenging you unless he's sure he's going to win. So let's write a program to simulate this game and see if your professor is trying to scam you, which he is. I'm apparently very desperate for money, apparently. So there's a number file video linked down here if you want to check it out. That goes over the particular strategy and statistics, but the long and short of it is the way this game is set up is that I have you choose the sequence first, and I get to choose a sequence that subsumes your sequence. So here, heads, and as soon as you threw a tail, so basically the only way you can win is if you throw 2 heads in a row. That's it. That's your only outcome. You throw 2 heads in a row followed by a tail. You have only a 1 in 8 chance of winning. Any other sequence, if I throw a tail first, well, the outcome's got to be my sequence would occur before your sequence because the end of my sequence is the beginning of your sequence. That's the trick. So I can always choose one that subsumes your sequence. And some of them subsume them a bit more than others. So let's go ahead and write a program to simulate that, though, because that's getting into fancy mathematics, and I don't want any of that here. So first, let's start off with the basic coin flip function, right? Let's just simply flip. We're going to import. I believe we've already imported random, and if you forget to import random, that is something I don't count off for, right? Because you probably imported it somewhere in the exam. It doesn't matter. If you forget to put in an import function, I really don't care. Okay. Import random. No, I didn't need to do that. I had it already, right? Importing it random doesn't do anything for us. Again, so def coin flip. I'll just call it flip, which will flip a coin. It's going to return heads or tails. Return. So here's our sides. I'm going to do it very simple. Sides is equal to, we've got an H, we've got a T, random.choice. I love random.choice. Okay? And sides. Sorry, and we're going to return that. For the exam for Monte Carlo, you're going to want to know 3 random functions. It's going to involve one of these things, okay? And you can get away with knowing only a couple of them, but these are the ones that you would need to know. You might not need to use all of them. In fact, I can guarantee you don't need to use all of them because you'll have to see. There's random not choice which given a sequence chooses something at random from the sequence, right? So we use that with heads, tails. Right, and that will return some result. There's random not shuffle, which given a sequence is going to shuffle that sequence in place, so it doesn't return anything. If you forget that bit, that doesn't return anything, that is, again, one of those really minor things they don't care about too much. Okay, but that's what you use to basically randomize something or to shuffle something around. Notice that I'm not even using that one in this problem, right? And the other one I'm not using in this problem, but that you might need to know, is random.randInt, which, given a low bound and high bound, produces a result between the low bound and high bound inclusive. This is the one thing in all of Python, the one thing where basically it's inclusive on both ends. Okay. I'm going to speed up because it's 3:11. My skills got another problem after this one. So, sides, heads, tails. Okay, return choice of that. Okay, def will play a game. The game involves taking two sequences, right? Sequence 1, sequence 2, right? And what we're going to need to do, and I'm going to move fast because of this, so I'm just going to tell the answer rather than explain, pedagogically getting there. So the idea here is we're going to just simply flip coins until we get to a winning sequence. So what this involves us doing is basically I'm going to create this this variable called flips. It's going to be an empty string to begin with. And what it is going to be is we are going to keep flipping coins until the last three characters of this flip are one of our results, right? So we just keep flipping until. So while flips the last three to the end, actually let's do it as a while true loop. I hate doing that, but it's the quickest way to do this. While true, we're going to keep doing this forever. So we're going to do flips is equal to plus equals flip. We're going to add another coin there. We're going to add another coin flip there. Flip a coin, add it to the end of our sequence. And now we check, hey, flips -3 to the end. If -3 flips, if the last three characters of the string flips is equal to sequence 1, let's go ahead and return that as true for you winning. And then there's not else there. We're just going to say if the last three are my sequence, return false. And if it's not one of those two sequences, we just got to keep going. Make sense? So this game is just going to go on forever until there's a winner. And eventually there should be. It's very unlikely that this statistically just fluctuates until there's not a winner. Right? Print game. And I'm going to just do HHH TTT, which isn't the trials we did, but I never closed that. True. Our game was head, head, tail, and tail, head, head. So false, true, false. Okay, now let's actually do our Monte Carlo and see how often this we win. So this is going to pretty much be very, very similar to how we do all of our things, where basically we have some number of things we're counting. In this case, it's the number of times he wins. That's going to start at 0. We're going to have some number of trials. Number of times we do this. Trials is equal to, let's say, 100,000. On the exam, I'll say how many simulations I want you to do for blank in range trials. We're going to do this game. And we're going to say, hey, if game is equal to the thing I want to count, in this case true. I didn't need to necessarily put true, but again, wins plus equals 1. And then we just print out wins divided by trials. Run. And as I said, quarter chance winning. I said 1/8. That was wrong. You only have a quarter chance winning. Again, I just keep hitting keys left and right. So there you go. Those are the actual odds of you winning the game. Okay. If you're interested in the math, check the link. I got one more problem for you. Another guaranteed problem on the exam. This one's, again, kind of super easy. Once you've mastered one, you basically know how to do this one, which is given a string, write a function that returns the most common most common letter in the string. Use a dictionary to do this. So please wait before going. This is important. Def, most common. So here is some text. We want to find the most common letter in the text, right? So the other common variations of this problem are most common number in a list, most common word in a list, most common word in a string. And in that case, you want to split on spaces, right? So most common letter, though, is, so we're going to create our dictionary. I'm going to call it our count is equal to an empty dictionary, okay? And we just simply say for letter in text. So we check every letter or everything that we're iterating over. If we have to create it, we create it. Otherwise, we just directly go into it. And basically, we look through the things we're counting. It's all very simple. We say if letter not in count. So if the thing we're counting is not in our count of things, then guess what? We've seen it once. Count of, in this case, it's a letter, so we say count of letter is equal to 1. Else, well, so if it wasn't there, it's there now. And if it is there, we've seen it one more time, so our count of letter plus equals 1. We increment that, the number of times we've seen that, by 1. Make sense? So we basically say, hey, to count everything, we figure out what that thing is, we iterate through it. If we haven't seen it, we've seen it once. If we have seen it, we've seen it an additional time. Now that we've got our data, we figure out which one's the most common. Okay? Most letter, okay, is equal to, I'm not going to, so yeah, I'm going to do it like this. Most count is equal to 0. So what we do is we say for letter in count now, for each letter in the count that we just did, if the count of that letter is greater than most count, then most count is equal to that. Then we found a new, better candidate for the thing we've seen the most. So we say, hey, we've seen this thing the most. We're going to keep track of the number of times we've seen it. If we've seen it more, we're going to keep track of the number of times we've seen it. And also make note of what that letter actually was. And that's it. We then return the one that we saw the most. Control save. Okay. And I think that's it, and I just had just enough time. All right, again, those extra problems, if you need more practice, go over them. Good luck on the exam. Remember, you do to get that cheat sheet. Remember the rules that I said about it. Just make sure that doesn't interfere with your partners, or not your partners, but your, the people next to you. Have a good day. If you need to take it via DRS, let me know about that. If there's any issues with that, let me know about that. Otherwise, come and see me. I got to get these uploaded. That's my next task.